You probably heard Elon Musk talking about going to Mars. In fact, he calls it the gateway to Mars. That may be a slight dig at the lunar gateway that NASA's doing, but fundamentally, he's just saying, we need to go to Mars, and here's a ship that'll help get us there. That is Starship, and they just completed flight test number 3. It was launched on March 14th. It basically was nominal, in most ways nominal meaning good, meaning it worked as expected. It made it to near orbit, which was the plan, but even more basically, it didn't damage the launch pad, so now they're well past that problem that they had on test number 1. All the engines fired and completed their full duration burn, which they had before. The hot staging worked, meaning they start the second stage before they release from the first stage. That was risky for such a big rocket. They've now demonstrated that works twice. They got up to orbital speed and altitude, which is really what the goal was. And it looked like the thermal tiles held together, so they stuck to the ship much more than happened in the earlier tests. One way to look at this, still the way it gets reported in the news is spaceships blew up. But, when you get down to it, where were they even blowing up? It's typically after they did what they were supposed to do. All of this is related to recovering and reusing, in this case, both first and second stage. Right now, you could say this rocket has already demonstrated it can move a large quantity up to orbit. Everything is related to really reuse. That's something that people lose sight of. They say it's blowing up. Well, yeah, but other rockets don't even try to do what they're doing here. Here's an example along the way of the hot stage separation. I've got a bunch of slides copying the video as the launch video showed. The way you read this, like on the far lower left corner there, they're showing you which booster engines are burning. So in this case, there were just 3 in the center. Those are the ones that are gimbaled, meaning they can angle so that they can make corrections, angle the thing a little bit differently. The ones around the outside ring are just fixed. They just go straight down. And the ones in the middle, I think, are gimbaled too. The one on the right, that's the second stage. They had just started up the second stage engines, actually all 6 of them, and I think the display was probably in the process of just changing over. Because normally when the engines are off, they just show those little hollow circles like you see on the far left side. So here you're looking down from the second stage, and you're seeing the firing going on. You're seeing the control fins there, which are associated with the second stage. And then down below it, there's the first stage, which still has some engines going. So that's what you're looking at. They got some new milestones because it went past the previous test. First of all, they managed to do the complete flip. The ship goes up, the stages separate, the first stage has to flip over and head back, and it tries to head back toward where it was launched from. And it blew up last time. So they now have gotten past that. And they did the full burn, meaning they slowed down as much as they needed to go into a coast phase, and then they were coasting down. And actually, they coasted back within about 6 kilometers of the ocean, but they did lose control. It was kind of a rolling oscillation. We call roll, if you're thinking of how planes or ships are rotated. It rotates left to right, indicating a control problem. Here we have a model that somebody is going to win. So it was going like this. Anybody who's ever worked in controls indicates, okay, you got a problem here. Now, it might be that it's badly tuned, the control. More likely, something probably wasn't working quite the way it should, or the model that they used to build it wasn't working quite the way it should. And these are all things that are, kind of new to Starship. So it's not the kind of thing they can test out so easily. This is how they find out if their models aren't good enough, fundamentally. You can't get good control if you can't really get a good model. What happened, though, they were losing control, and also they probably had an engine failure on restart. Maybe by now they've sorted that out. The last time I looked, they hadn't really definitively said that, but it sure looked like it. Anyway, finally it blew up. Actually, at only 460 meters, pretty close to the ocean where it was supposed to fall. So that was the booster. But in any case, they made it a lot further than they had before. Long term, the goal is for it to come back and land either on a platform in the ocean or actually back at the original launch site. And they're getting closer. The first step, they were just hoping to land it vertically and drop down into the ocean. They didn't quite get that. One thing that happened on both the first and the second stages was they did have these rolling kind of problems. The thermal tiles are supposed to take care of the heat. You're getting a lot more heat on the lower side. And the problem is when it rotates, the upper side is exposed. It's something they have to worry about. Now we're going to look at the upper stage. Normally the thing goes up, so it completed its engine burn to get as high as it was going to go. And then it's just supposed to coast along for a while, heading along where there's essentially no atmosphere to speak of. That's further than they ever got before, because the last time it blew up at that point. There were 3 tests they wanted to do. One was transferring fuel, and they were just doing it between a couple of tanks. There's a little tank way in the very front of the ship, and there's a big one in the middle. And they were just transferring fuel. They need to show they can do that in zero-gravity conditions, because they need that to go to Mars. Even to go to the moon, fundamentally, you need to get a bunch of fuel up there in a fuel depot, which will just be another one of these. and transfer fuel to it multiple times to basically gas up so they can then go to wherever they're going, the moon or in the future to Mars. So they were testing that out. The result was they said it worked, but of course we can't really tell, and they didn't really have final results on that. They were also going to test the payload door opening, specifically for the style of launching satellites that they want to do for their own Starlink. I've got a slide on that later. And also just testing out the control. I've got a slide on that later too. They also, at this point, established the first hypersonic reentry. Now, once you've gotten up there and as you start to come down, you're going at orbital velocity, which is at that altitude is like 17,000 miles an hour, 25 times the speed of sound. That's hypersonic reentry. They hadn't actually done that before. So this is the first, and that's why they have those tiles. Now, as I said, it turned out they had a rolling problem, and so the thing was upside down even at times, and as a result, that definitely hurt it. So they found out that they need to improve their controls. But basically, they're testing the heating. Are the tiles good enough? They're testing the control systems and just the aerodynamics in general to make sure they understand how the vehicle is actually going to work. Because you really can't test it that well in a ship this big. You can't just throw in the wind tunnel. You don't have a wind tunnel that big, especially a supersonic one. And just to point out on this display, like the lower right corner here, you see, indeed, the engines are off. That's what it looks like when they're just coasting. And they show the orientation. If you're looking along the bottom there, there's a little place they're showing the thing is slightly angled up. It's pitched slightly up, which is how it was supposed to be at that point. I just want to show these things because these things change as we look. Now, one thing you'll notice in this picture, they're showing that the Earth looks kind of vertical to it here. That's because the thing is rotating. And every one of these, if you looked over time, every time you looked at it, the Earth was in a different position because it was rolling. They lost control, which ultimately would lead to its demise. As far as the in-orbit fuel transfer test, this shows a diagram of an earlier version of Starship. Every one of these ships has what are called header tanks. It's a small tank. They keep those so that they can guarantee that there's no vapor anywhere. They keep them under high pressure on the front end so that when they want to restart an engine, for instance, even in zero gravity, they don't have to worry about it just having a bunch of gas and liquid kind of floating around aimlessly and the engine's not working properly. So that's called a header tank. And that's a typical kind of thing they have. The test they were doing was just moving some stuff from the header tank over to the main tank, which is there kind of in the middle of the thing. They moved about 10 tons of liquid oxygen, or at least that was the plan. The results haven't really been published yet. NASA is quite concerned because NASA needs this to work. So in the future, in general, this is sort of the conjugating paramecium kind of a picture. I don't know how thick those pipes are supposed to be, but somewhere in there, there'd be pipes so that you're going to be passing fuel from one ship that came up laden with fuel, fueling up the other one. So that's what they expect to be doing in the future. And as I said, that is important to NASA, specifically Artemis 3, which is the very next moon launch. That's the one that will actually take a crew to land. If you're going to do that, though, it takes multiple loads of fuel for one of these starships going up, multiple loads of that as the payload to go up. So what they do is they start off with an initial launch, which should be the one on the left over here. It goes up, and then several launches are done to go up and fill, and then they return. So that whole cycle is not quite shown on here, but there'd be multiple launches and returns to Earth. At some point, then, they launch the SLS that actually is carrying the human crew. They take it up, and they meet up in orbit, and they transfer the crew to the human landing system, which is a Starship, one of these, except it doesn't have fins because they don't do any good around the moon. They're never gonna see an atmosphere, so they don't have fins and a few other things associated with atmosphere. They would then go and they'll land, and then when they're done with their mission, then they'll take back off, and they come back, and the crew returns to Earth. So that's the whole thing. But all of this depends on refueling in orbit. So this matters to NASA. It matters to SpaceX and for all future missions, including Mars. So I mentioned the testing of the payload doors. They're calling it a Pez dispenser for people who are younger. That was a kind of a candy. I don't know if they still even have them, but they were sort of like chalk. They were in a tube like this, and you could shoot out like a little pellet, one at a time, kind of a chalky kind of a candy. That's what they're doing is they're going to send out the satellites kind of in little flat packs, one at a time, shooting out the door. And the door, you can see it here at launch. It was closed. It's this little thing right in the center of the picture. That's the initial outside view. This was right during the takeoff, 4 seconds into the launch. All the boosters, engines firing. This is what it looked like inside. And so what they did is, once they were up, the second stage is just floating in space, then they had pistons, which are shown here, which open a door. Now, it's a little hard to tell if you look at the picture by itself, but Look at the bottom center of this picture. There's some little traces of gas there. They're just kind of open to space at that point. There's still some moisture or whatever kind of wafting its way out. And if you look at the next one, it looks kind of bluish, but that's the door closing. So they started off with it completely closed. They didn't show that, but then they showed the door open. Some of the earlier parts of the launch, you could see more and more of that vapor there. And then if you watch again, that door was closing. Now, it wasn't actually clear that the door ever got fully open or the door got fully closed. You couldn't really tell that. I mean, I'm sure they know, but we couldn't really tell by looking at it. So some people have raised questions about that. But anyway, at least they've started now. They've done some testing, at least on opening and closing the doors, which will be a necessary part of deploying satellites.
In the live video, that door looked awful. As they were moving it around, it kind of was all over the place.
Yeah, it wasn't completely convincing, but at least it's a start. Note again that the craft pitch here is essentially zero. It's just going along, kind of coasting. Now, the next one, you'll notice here it's pointing up. They've lost control at that point. It should not be pointing up. The pitch is wrong. So there's two problems. The pitch, meaning it's now pointing up instead of going sideways like it was supposed to be doing. And the other thing is it's been rolling. So there's at least two axes of rotation that are screwed up. So that, they've lost control. But it doesn't hurt it right away. Now, as I said, it's pointing up. You'll notice also, if you look down, those white things in the bottom, those are the clouds. So you're looking down directly at the surface of the Earth, which you weren't in some of the earlier pictures. Remember looking back, one of the earlier second stage. Clearly, there's a lot of rotation going on here that is not really desired. So they have to work on that. Now, the other interesting thing is that when you're going that fast, you get plasma. What happens is you're hitting the few particles of air that are there, you're hitting them so hard, they essentially dissociate into ions. It's called plasma. That looks like it might be some kind of engine. Now, all that red kind of look there, that's not. That's just plasma. And that was interesting because that was also something new. Normally, when you got a rocket coming down, you're trying to communicate with the ground. Well, all that plasma is forming in the front, the front and immediate sides of the vehicle. You can't transmit a signal to show a picture of that. But here, they're transmitting to satellites that are above it, so they could. So they actually were able to show this. That was something new. Nobody had actually seen the plasma that gets generated. No one had ever seen that during that descent phase. This was actually during the descent. And here's yet just another scene here. Again, that sure looks like it might be rocket engines. Nope, that's just plasma. And that was one of the more dramatic ones that were there. So they did have problems. It all comes down to control. They couldn't control the attitude, meaning the orientation, pitch horizontally, vertically, or the rolling. And of course, once again, the thermal tiles then are not doing their job because they're not in the right place all the time. So they had a problem. They did skip one test, which was an engine restart. You want to make sure that you can start your engine in space. They hadn't actually done that yet. But because they'd already lost control, they didn't want to make things worse. So they didn't do that. And then the ship, finally was just lost during reentry. And in terms of orientation here, this is a case where here the ship was pointing down. It's just clearly lost control.
Following the main presentation, we discussed the general trends driven by SpaceX, in particular reusability and how it started the drastic cost reductions for space access. Starship takes this to the next level and should really open up access to space. Like the semiconductor revolution, drastic decreases in cost lead to entire new possibilities for applications and industries.
The last Starlink flight is also interesting in one thing, and that's that for the first time, they reused a booster 20 times. So that's pretty impressive. They've got quite a few that were in the teens now, but it's amazing. They're sending up so many launches. They're probably going to do 150 or so, and they only need a couple of boosters to do this. They really are turning into the airplane model where you don't have to throw away the airplane after every trip, and that's why they can keep their costs so low. They've changed the whole model, and they've changed everything. You figure Falcon 9 has reduced costs from the era of the space shuttle by a factor of at least 10. It may be even 20, depending on the time period you pick. I mean, that's huge. And for instance, you think about the semiconductor revolution. Well, every couple of years, you doubled your power, you cut the size. We're not on a curve that's dramatic as that, but a factor of 10, that enables a whole lot more applications. And Starship is another factor of 10 at least. I mean, maybe it'll be 100, who knows. But you can probably count on at least 10. It's not just economies of scale. It's the fact that you're reusing the second stage as well as the first stage and having a lot of reuse. If you launch once a year, it wouldn't make any difference. But if you're going to launch hundreds of times a year, it makes a huge difference. And so they're making it possible for us to get to space. Necessary condition, you got to have cheap access to space if we're going to ever get there in a meaningful way. it isn't enough. You also need life support. You need agriculture on the moon. How do you mine on the moon so you can use some of the dirt to build your bricks or build factories or whatever you're going to do? All that can follow, but none of that is even worth thinking about until you have a launch capability. And that's what they've accomplished on the Falcon 9 and now coming up.
Starship.
Any other comments or questions? Yeah.
Yeah, one thing that Elon Musk has done is move the goalposts. It's not just reusability, which everyone laughed at. Oh, you're going to reuse a rocket? Like, that's impossible. And then it's like, you're going to reuse it 10 times? Well, that's just, that's not going to work. And now 20 times, it's just like every 2 years or so, he's moving the goalposts for everyone else.
Yeah. Well, and then reusing the second stage, which is also, of course, everybody said, well, that'll be impossible because it's already up there so high. It takes a lot more fuel to get it to come back down to Earth. Well, they're working on it.
Very reasonable people in business who carefully explain in monographs and reports why it was impossible.
Yeah.
Why it was possible, but economically not worthwhile.
Yeah.
And now it's like,
Well, and part of that's from having better control over the vehicle. So, for instance, both the first and the second stages in Starship, I mean, other than the initial turns, they're not relying on the engines firing to slow them down that much. They're just relying on the atmosphere slowing them down. And even starting from way high, they have to get down somewhat. But once you get anywhere close to an atmosphere, they're letting the heating tiles take over. And they're doing a much better job of that than anyone did before. So they literally just kind of coast down until it's almost time to turn the rocket engines back on, flip over and then land. And that's very different, even from, say, moon landings, which typically you turn on your engines and you keep them on the entire time, all the way from being in lunar orbit all the way down to the ground.
Discussion continued on reusability. Doug felt that existing vendors may adopt it, but not push it hard enough. For instance, the Boeing Starliner capsule carrying crew to the International Space Station might be reused up to 10 times, but with a 6-month turnaround. The Orion capsule used in the Artemis moon program only has parts that are reusable, and also will take a long time to refurbish. With Starship, they're working very hard to make sure that refurbishment will be fast and inexpensive.
So how long does it take to turn it around? The space shuttle was reusable too, but it cost
a lot to refurbish and took a long time. It wasn't cost effective.
Whereas all this stuff has been designed to be just much, much simpler and to hold up. That's why they're using stainless steel. It can take a lot more heat. It doesn't matter if it gets so hot. It doesn't melt.
There was also a lengthy discussion on what it would be like to work for SpaceX.
It's kind of the Silicon Valley approach. It's pretty much high pressure, long hours. You give it your all. Maybe you burn out, maybe you don't. But it looks good on your resume, even if you burn out. Everybody knows that, okay, at least you participated in that, and that's worth something.
And the word's got around. It's like, you worked for that company for a while, for like any length of time, and you could stand up to that. You could stand up to anything.
Yeah.
And it was like working for NASA in the 1960s.
Okay, that ends my talk.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.